Hi, Assalamu alaikum. How are you, students? Hope you are doing well and you are studying your lessons. Okay, again Faizullah Omar with you, and today we are going to study atomic radius and ionization energy. So let's see, what does these two terms mean? Okay, students, let me define what's atomic radius. The atomic radius is a distance between the nucleus and the outermost electron of the atom. Example, this is a nucleus, and let's say that this is the outermost electron. This distance is known as the atomic radius. Before defining the periodic pattern of atomic radius, let me show you how can we find the atomic radius. Finding atomic radius of an atom, we can find with the help of van der Waals radius, covalent radius, and metallic radius as well. I have brought here two types. In van der Waals radius, half the distance between the nuclei of two neighboring atoms is known as the atomic radius. For example, we know that there is van der Waals intermolecular force between two helium atoms. Let's consider this is the nucleus and this is the shell of the helium. This is the other nucleus and this is the another shell of the helium and helium. Now we have to find out this distance between the two nucleus, and when we divide it into two parts, half the distance will be the atomic radius of the helium. And when it comes to the covalent radius, for covalent radius, half the distance between the nuclei of a molecule. You can see over here we have a molecule. This is let's consider that this is a molecule of hydrogen, or we can say H2 molecule. Now you can see the distance between the center of two atoms is known as covalent distance because there's a covalent bond between them. This is a molecule. So when we divide it into two parts, in this case we can say that it's the atomic radius of one atom or hydrogen. Let's work upon an example. If distance between the two neighboring iron atom is 2.48 angstrom, find the atomic radius. As I've told you that it is a 1/2 distance of the covalent radius or van der Waals radius. So we can write it something like this. 2.48 angstrom divided by 2. We can say that 1.24 angstrom. This is the atomic radius of an iron atom. Okay, let's say the periodic pattern of atomic radius. Like what kind of trend does it have in the periodic table? Atomic radius within a group increases from top to bottom, and decreases from left to right, or we can say increases from right to left, or decreases from left to right. Over here it is decreasing, and over here it is decreasing and increasing. Why it is increasing from top to bottom? Because we know that we have studied in periodic table, every period has a within every period one shell adds up. For example, in the first period there was one shell, in the second one two shells, and when we arrive to the seventh period there will be 7 shells, which means that the radius or the distance from the nucleus and the last electron is getting bigger. And that's why the atomic radius will also get bigger, which we can say that it is increasing. And when we say that it decreases from left to right, we know that, let's give an example of the second period. We see that lithium, beryllium until neon, they all have 2 shells or 2 energy levels, but lithium has 3 electrons and 3 protons inside, but the neon has 10 electrons and 10 protons. We know that the proton and electron have opposite charge, so attraction force between the proton and electron is much more higher in the neon than the lithium. They both have same energy level. They both have 2 shells. The attraction force causes the atomic radius to be decreased. That's why when we go from left to right, the atomic radius decreases, or vice versa. We can also say that when we go from right to left, we can say that the atomic radius increases. Okay, students, this was about the atomic radius. Let's study another topic, ionization energy. Let me define it. Ionization energy is the minimum energy required to remove one electron from an atom or ion in a gas phase. For example, let me draw an atom over here. This is the nucleus, and for example, this is the first shell, and this is the second shell. Let's consider that this is lithium atom. Now we want to remove this electron out of the shell of lithium. So in this case, we need some energy because it doesn't want to leave the shell. So the energy that is needed to remove this electron from a single atom, we call it ionization energy. The symbol for the ionization energy is delta Hi, and the unit that's used for ionization energy is kilojoule per mole. This is a bigger unit, and when it comes to the atomic level, we can use another unit that's electron volt. And let me tell you something, as we have studied the atomic radius, as much as the atomic radius gets smaller, the atom doesn't want to lose electron, so ionization energy will get higher. If the atomic radius is small, ionization energy will get bigger or higher. If the atomic radius is big, in this case, ionization energy will get lower or smaller. Remember that. Okay, let's go further. Next. Patterns across period and groups for ionization energy. The general trend is for ionization energy to increase, moving from left to right across an element. Period. Moving left to right across a period, atomic radius decreases, so electrons are more attracted to the nucleus, which means that ionization energy will increase. And the general trend for ionization energy from top to bottom down in a periodic table or in a group, we can say that as much as we go down in a group, a valence shell is added, which means that we will have much more energy levels. The outermost electrons are further from the positively charged nucleus. They will far away from the positively charged nucleus. Let me give an example. This is hydrogen and this is lithium. We can see that lithium has two shells, hydrogen has one shell. So it's much more far than the nucleus. This electron is close to the nucleus. So in this case, we can say that the atomic radius of lithium is bigger than the hydrogen. So it will be easier to lose electron. So that's why as much as we, when we come down from top to the bottom in a group, the ionization energy will decrease, or vice versa, or the electrons are easier to remove. Let's check ionization energy in the periodic table. As I told you that ionization energy will increase from bottom to top, or vice versa. It will decrease from top to bottom. As you can see that hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium, the energy levels are adding one by one. It has one energy level, 2, 3, 4, 5, 6, and 7, which means that in the francium, the electron is very far from the nucleus. So it is easier to remove the electron, which means that it has the lowest ionization energy in this group. Or hydrogen has the biggest or the highest ionization energy in this group. Or according to the period, I told you that as much as we go from left to right, the ionization energy will increase. Why? Because the atomic radius gets smaller. The attraction force between the nucleus and the furthermost electron will get higher. So this is the trend or the pattern across a period and groups for the ionization energy. Thank you for watching. If you have any question and suggestion, write in the comment section below. Please don't forget to subscribe our channel and give a thumbs up. See you. Goodbye.